We are going to be making use of the fact success physics past question. One thing I so much love about this past question is that most of their questions are being arranged according to their topics. So it makes it easier for students who are preparing for exams like JAMB, WAEC, NECO, GCE to use it in their studying in preparation for the exam. So today, my name is Peter. I'll be the one teaching you how to solve problem in elastic properties of a solid. So if you are new on this channel, kindly please subscribe. In this channel, our major work is to teach you how physics questions in physics can be solved at ease without any stress or mental brain works. So from here, I want to give you all the formulas used in solving problems in elastic properties of a liquid as this. The first thing we have it as F, force is proportional to extension, and later we have it as first is equals to Ke. Our K is known as the constant. We have the third one as, when you make K the subject of formula, so you have it as K equals to force all over extension. So from here, don't forget that from the derived quantity in early of our video, we've said that the formula for force is still the same thing as mass times acceleration. But before we get there, let me quickly introduce this for you. Since we have that K is equals to force all over extension, so we can say it's still the same thing as having it as F1 all over E1 equals to F2 all over E2. Now, I want to extend this. Don't forget that the formula for force is still the same thing as MA equals to MA all over here. Initial length minus original length, final length minus original length. So from here, for Young modulus, we can say the formula is equals to stress all over strain. The formula for stress is the same thing as force all over area. While the formula for strain is still the same thing as extension all over length. So this strain here is what the question asks us to make use of. The question says, what is the strain? So from here, first thing you do, I advise most students whenever they are solving questions in physics is that the first thing they should do is to never to forget to write out the parameters from the question, the given value from the question. So we can say the given value, we have to pick it according to the way the question is being given. So the question says, a piece of rubber 10 centimeter stretches 6 millimeter when a load of 100 Newton is hung from it. What is the strain? So from here we can say we have our length given as 10 centimeter. But don't forget that the SI unit for length is meter. You have to convert this 10 centimeter to meter. So it's the same thing as 10 divided by 100. Move here, which is still the same thing as 0.1 centimeter. While for extension, we have our extension given as 6 millimeter. Remember, milli means 1000 divided by 1000. So we have it as 6 divided by 1000. So when it moves 1, 2, 3, we have it as 0.006 meter. So from here, we can apply the use of the formula for what? Strain. Formula for strain, don't forget, is the same thing as extension all over length. Extension from here is 0.006 divided by load is 0.1. So when you use 0.1 to divide this, our final answer is still the same thing as 0.06 as the final answer. Don't forget that strain does not have a specific SI unit. One, let us check. The SI unit for extension is meter. The SI unit for length is meter. When meter cancel out meter, so no SI unit. Let me put it here. M go against M. There is no SI unit. We have our second question given us. If a load of 5 Newton give an extension 0.56 centimeter in a wind, which obey Hooke's law. What is the extension caused by the load of 20 Newton? Remember this. This question is 1987 question 14 past question in normal JAMB past question. So from here, we have our option A as 1.12 centimeter, B 2.14 centimeter, C 2.24 centimeter, and D 2.52 centimeter. Remember that the SI unit for extension is based on your option. Since our option is giving us the value for our extension as in centimeter, so you have to use it the same way as centimeter. First thing to do, remember, don't forget, write out your parameters from the question. We have our force, which is F1 equals to 5 Newton. Extension, which is E1, is given as 0.56 centimeter in a wing, which obeys Hooke's law. What is the extension, which is E2 unknown? What is the extension caused by the load of 20 Newton? F2 equals to 20 Newton. So from here, apply. Remember, you have F1, E1, F2, F2. So remember from your parameters that you have F1, E1, F1, E1, F2, E2, F2, E2. That means you are going to make use of this. So you can put it as F1, E1 equals to F2, E2. Our F1 from here is see the same thing as 5. E1, 0.56 equals to E2, 20. F2, 20, while E2 is unknown. So from here, don't forget to what? Make E the subject of formula by doing what? Cross multiply. So we are going to have it as 5 E2 equals to 20 times 0.56. So make E2 subject of formula. When you divide both sides, you have it as E2 equals to 20 times 0.56 all over what? 5. So when you use this 5 to multiply this and you multiply everything together, you have your final answer as 2.24 centimeter. Option C is the correct answer. So you can see how simple solving questions in elasticity is if you know how to derive this formula often. They are not hard. Always remember that our F symbolizes force, E symbolizes extension, L1 symbolizes initial length, while the LO symbolizes or stands for original length before a force is being applied to extend the object. L2 is given as the final length. So we have the third question given as a load of 20 Newton, cross-sectional area 8 times 10 raised to the power of minus 7 meters square, produce an extension of 10 raised to the power of minus 4 m. Calculate the Young modulus for the material of the wire. If its length is 3 meters, we have our option as all this. Past question 1997, question 15, JAMB past question. So from here, don't forget, write out the parameters as one of the laws to obey. We have our F1 from here given us 20 Newton. Cross-sectional area A given as 8 times 10 raised to the power of minus 7. We have extension given as 10 raised to the power of minus 4 meters. So we have our Young modulus. The symbol for Young modulus is Y, is unknown. So you leave it as this. And we are given from the question as we are given our length also, L, which is given as 3 meters. The formula for Young modulus from here, don't forget, stress all over strain. So we have Young modulus equals to stress all over strain. So I present my whole formula in this way. Y equals to F over A times divided by E all over L, which is the same thing as FL all over AE. I present my whole formula as this. So we have Young modulus equals to force is 20. Put it 20 times length. Length from our parameters here is 3. 3. All over, we have here area. Cross-sectional area from the parameter is given as this. So when you convert this from standard form to ordinary number, it becomes something of this kind: 0.00000008 times, we have extension. Our extension from here is still the same thing as 10 raised to the power of minus 4, which is the same thing as 0.0001. So when you multiply this and this together, and use this to divide this, your final answer is going to end up in 7.5 times 10 raised to the power of 11 n per meter square, which is option B. One thing I just did here that makes it very, very easy for me, I convert this division sign to multiplication, where my length will go up and my extension will come down. F times L will give us FL. A times E will give us AE. So that is for that. So we have the fourth question given as: a spring of length 25 centimeter is extended to 30 centimeter by a load of 150 Newton attached to one of its ends. What is the energy stored in the spring? Well, we have our option as this. Last question 1994, question 11. So write out the parameters from this question. So we have our length. Original length is equals to 25 centimeter. We have extend, LO, L1 given as 30 centimeter. We have load, which is F, giving us 150 Newton. So the question says calculate the energy stored in a spring. And at the same time, don't forget that whenever we make mention of energy stored in a spring, that means we are referring to potential energy that are not in motion. They are always stagnant. So we have our PE equals to unknown. So from here, we can say our half equals to, remember 30 minus 5 is 5 centimeter. Convert our centimeter here to meter. It's the same thing as 0.05 meter. So we can say times 150 times 0.05. 2 here 1, 2 in 150 is 75. So we can say PE equals to 1 times 75 times 0.05, which will give us our final answer as 3.75 joules is the correct answer. So this is where we've come to end this lesson for this session. Like, comment, and subscribe. Thank you.